The PhET Interactive Simulations project at the University of Colorado Boulder creates free interactive math and science simulations that help support effective learning. These simulations display visual mental models to make the invisible visible. The use of real-world connections helps students more easily understand STEM concepts. While these are great solutions for many students, the simulations rely heavily on vision. So how can we adapt this successful interactive way of learning to support students who are visually impaired? Our teams in the Sonification lab have focused on enabling an accessible experience for the built-in atom simulation. To establish an effective interactive simulation for visually impaired students, we've been collaborating alongside a team working on making the user interface accessible and another team researching feedback using Sonification. Our research explores how air gestures could be used to interact with virtual objects. To track and input hand movement, we decided to use a Leap Motion device, which offers a JavaScript API that allows us to integrate with the built-in atom simulation. Because the Leap Motion device detects hand movement across a limited 3D space, we explored the use of 3D mapping as an auditory cursor. This would provide feedback to communicate the location of the user's hand and if it had moved out of the trackable area. In the built-in atom simulation, when the user moves their hand to a selection area, the sound feedback is designed to be specific to differentiate between items, such as protons and electrons. Our prototype allowed users to select and move an object in 3D space while recording their hand movements and displaying confidence data, enabling us to review user tests. From reviewing previous studies, we learned that when prompted to perform a task, without visual feedback, the gestures people naturally chose to use differed between participants. So rather than deciding what gestures users would have to perform to interact with the simulation, we decided to understand the gestures that visually impaired students would naturally use and design the system based on our findings. We designed our study to elicit free hand gestures from our participants. Each participant would be asked to move a certain object to an area in 3 or more different ways within their body frame or reach. Working towards a mutual goal with the other 2 PhET accessibility teams, we were able to design this study and a plan moving forward. The study will be administered with students at schools for the visually impaired in the coming semester.